demands and those principles, which I'm going to be discussing in one of the upcoming seminars. The code basically tells you to put your truck in the worst position and get those demands. So the whole idea was to give some background in terms of, okay, guys, this is what's happening behind the scenes. Yeah, you might have studied it back in second year of engineering, but you've probably forgotten all about it and you've never really, let that sort of seep in. So in these cases, what we do is we might open up SAP for 15, 20 minutes and run a line model, but you can always check with the influence lines and some of the ordinates. They come in as a handy tool. And then if somebody's into programming or whatever, you want to make an engine of your own, you can easily take some of that and implement it.
Yeah. Okay. So Harry, just to maybe round that up and going back to your specific question, you're absolutely right. During the conceptual phase, when you're dealing with girder bridges, if they're continuous 2, 3, 4, 5 span, whatever it is, unless it's highly curved, just to get the live load demands, what we would do is just set up a simple, line model. If the structure has a high degree of curvature, you might want to put in a bit more, I guess, level of complexity in your analysis, but we try to refrain from usually, putting out like a full-blown FEA model during the conceptual phase. And what you'll find in example number 2, you'll see how that even for a lot of the reactions, right, that you need at the piers, you can just do hand calculations and get them through a simple spreadsheet that you guys have already seen on the Shanders if you've gone that far in the course. But to get the positive and the negative moment demands on the continuous girder bridge, then we do latch on to a line model. But again, we do try to minimize detailed analysis as much as possible because we're trying to limit effort, and especially with experience, you kind of know where you want to be, right? So I think once you go through the second example, you'll see that when you're trying to pull, let's say, steel tonnage, there's a couple of little tools that we use to sort of land in the right ballpark. And sometimes we don't even go through a full laundry list of code checks also at the conceptual stage. There's some like simple rule of thumb checks that we have that you'll find out as you move on, not just for the positive moment, also for the negative moment region. So you're minimizing your effort, yet you're landing the right ballpark.
Okay.
Yeah. Good. Yeah. So feel free, guys. Any feedback on the course? Any further questions?
Yeah, you don't have to be very diplomatic about it. You can.
Yeah. So we're open to receiving the good, bad, and the ugly. As
yeah, we want to improve.
Don't be diplomatic.
Yeah.
I guess the one thing I can tell everybody is that this overall course that you're taking right now, we've split that up into 3 smaller courses for anybody else that wants to take it, because some of the feedback we were getting is that it's a fairly extensive and long course, especially for people who are also working. But one of the good news, I don't know if it's supposed to make you feel good or bad, is I think it should make you feel good, is a couple of universities that have been reviewing our course, one of them being University of Massachusetts, has accepted this course, the one that you're taking, the full course, as a graduate or PhD level course that they would offer their students either in the winter or next spring. And so, of course, for that, you've got to take it through the university system. But if you do that, it does count towards 3 to 4. I think that's not resolved yet. It could be anywhere from 3 that would count towards a graduate or a PhD degree.
But I think the takeaway there is that there's a professor over at UMass at Amherst who's thoroughly gone through the course, and they're very happy with the content. So it also gives us a lot of confidence in terms of putting something out there and then having it vetted by a real big name university and people in that sort of position to say, yeah, no, this is really spreading the knowledge and doing the, kind of doing it the right way. So I guess the thing is that you have a quality product in your hands, which we're hoping is giving you a lot of info. And what happened here? Oh, Okay. So yeah, so I think the good news is that, and we're also talking to UBC here, University of British Columbia. It might become part of their one of their certificate programs. That this is not just your I guess what I'm saying is your investment was done well. It's being recognized by big name schools. So it's you know, I don't mean to toot our own horn, but it's a good product.
Yeah, I guess the other thing is that a lot of younger engineers talk about that, you know, like, can you teach me how to run a software? Or they somehow think bridge engineering is all about, you know, running complex models and analyses. And people who've been in the industry for a while, they would tell you, Cousin is here and Varun's here also, and Luis, correct me if I'm wrong, but a lot of the bridge engineering is very simple. Like the more you progress in the field, the more you realize that the simpler you keep it, the more you latch onto the first principles, the better decisions you make. And you don't really need to do a lot of extensive modeling. I mean, there are situations where you do need to, but what we're trying to promote is this idea of practical engineering. You know, we're trying to get you guys trained from the get-go on how to be practical and how to make practical decisions, including, you know, all these multidisciplinary influences, constructability, trying to latch onto the first principles with regard to analysis. And also, yes, there is these 200, 300 page codes, but, you know, you really need to understand that what's really at work behind everything is physics. And physics doesn't change whether you're in India or you're sitting in Canada, right? So that's sort of the ideology that we're looking to promote. Cousin, perhaps, you know, with your experience and, you know, you lead a team of engineers in your office, what has your experience been in the course so far? Obviously, this is, you know, perhaps not as advanced for you. We appreciate that you're taking it, but what do you think the value is for especially the younger engineers with, let's say, you know, up to 10 years of experience?
Oh yeah, like I wanted to thank you both actually for putting these courses and webinars, and you have been very generous in terms of like giving away the knowledge and the experience. Yeah. I wish I had this course actually when I came to Canada a long time ago.
Yeah,
it would save me a lot of time and money. Maybe, you know. Yeah, but yeah, the course is very good, especially for younger engineers. Yeah, but I mean, for me, it still was like beneficial, like refreshing my memory and comparing things like the way I'm doing. Maybe like correct it myself or like make sure what I'm doing is right. But yeah, it's just like there is value in it. Yeah, very valuable. Yeah, for sure.
Just picking up on the thread of you know, keeping things simple, and yes, it's about keeping things simple, but it's also, as you gain experience, you start to think like this. What we're trying to do is open the younger engineers' mind to this possibility early on, because the earlier you start to think about it this way, the better it becomes. So one of my personal experiences early on in my career was at an engineering firm. This is probably early 2000s. And my assignment there was to design a railway crossing in a bit of a marshland. And the whole idea was to put a thick 700 mil thick slab on extended pipe piles. So they would drive the piles, and then they would have, this was a 2-span crossing, this really highly skewed crossing. And I did a model, a 3D model in SAP 2000. And this was just a very high, like a 60-degree skew. So I had to do the Woods equation, and I had to add the moments this way and that way. And it took me about, I think, about 4 to 6 weeks to come up with the design and the rebar and all of that after doing a bunch of analyses. Now, when the assignment was given to me, the person who gave me the assignment was probably, at that point, maybe 30, 35 years into his career, my boss, my manager. And he sketched something up within about 45 minutes the very day that assignment. just closed his room's door and sketched it up, and he had the rebar and kind of configured it. And after about I forget, it was over a month, I took my sketches to him. And in the meanwhile, we were talking, and he was trying to guide me and stuff like that. So I showed him my sketches and my rebar. He pulled the sketch out that he had made several weeks ago out of his drawer. And we were very, very close. So that's the sort of thing that happens with experience. And because you kind of start to have all this, you're like a very high level AI, right? Basically, that's what humans are. So as we go through our careers, we start seeing patterns as we gain more and more experience, and based on those patterns, we start to realize where the answer might lie. And I don't know if you guys have seen one of my little videos about analysis and design. And the big conundrum is, when you are given an open site, and you say, you go, okay, well, I'm going to come up with a solution. Well, it's great. I'm going to do an analysis, and I can do a 3D finite element analysis. But what is it that I'm going to analyze, right? So you have to have a starting point. And it's like solving one of those, third, fourth degree equations where you're taking a guess. If your guess is really far out, you're not going to converge to the solution very quickly, right? Whereas if your initial guess is close to the final answer, then within a few iterations, you're able to find the answer. You're able to land on the curve. So I guess what I'm saying is, it's very important to start off with a solution that's rather reasonable, and then you analyze it and then you refine it. But this whole cycle has to be started somewhere, somehow, and that's where you'll see in the second example we're putting into effect a lot of those rules of thumb that I describe in, I think, module C, where we're talking about the LORDs and the flange sizes and all that. And there was a bit of that in the first example, and the second example is showing you more of that. So it's really that starting point and how you're going to get the wheels rolling that then gets you converged to the final sort of answer in an efficient manner. And these days, with a lot of the design build projects, we don't have a lot of time. We don't have a lot of like a lot of money. So you got to start and you got to get there and get focused real quick. So that's been sort of the driving force behind this, is to give you some of those tools, but also change your mindset from just pure analysis to, okay, think about the first principles, think about where your starting point is going to be, and then start to hone in on the design. Now, of course, when you're going to do the final design, you have to do all the checks per the code, whether it's the Indian code, the Canadian code, AASHTO, whatever it is that you're using, that has to be done at the final stage. But if your initial answer is close to being right, then you're not going to have a lot of heartache to finish everything.
Mm-hmm. Good. Hey, Varun, I specifically wanted to ask you, are you finding this course useful, especially with the kind of structures you're involved in? You've been working with Stratos and more complex, longer span bridges, but I'm curious to hear your feedback on whether, from the perspective of the kind of project you're involved in, also in the Indian context, that is this course being beneficial to you or not?
In India, whatever training we had, whatever I worked in 10 years, right, it was like on-the-job training, right? Mm-hmm. We never got a truly crafted training as such, right? So I would say that even though after gaining such a good experience, I would say I really learned something from the course. And one more plus point is that I didn't work with too much in AASHTO and never in Canadian codes, right? Yeah. It was a new thing for me in that way also. And there are many different things which engineer overseas do very minutely, like fatigue check, right? Mm-hmm. Fatigue check is not done in India. No one knows about that. Really? Yeah, right now in India, there is a fatigue load defined in our code, but no one is able to use that properly. No one knows about it as such.
Well, then you should join these fatigue seminars that Sakib is putting out next month. Yeah. No, please carry on. Sorry for interjecting.
A lot as such, but yeah.
Good. That's good. And Arbaz, you're also finding this useful?
Yes, sir. Actually, on in my first year of my job, I pushed my boss to take a box culvert. I was not really knowing what I was applying because I have just copied. We usually do in Chat Pro. So whatever things, I mean, the previous projects we have done, I used to copy the same thing. But now when I see these codes, when I go to each and everything, I'm just correlating my previous experience with this what I'm learning now. So right now I'm really feeling satisfied. That is what I'm feeling right now.
That's important. That's important for an engineer to feel satisfaction, right?
You need to have a mapping back to the, exactly.
Yeah, and I also just want to point out that Sakib sir has given up 5 videos which he has produced in YouTube. I was really, I used to watch it time to time. It is really an informative videos. Thanks.
That's really good. Yeah, I think one thing I want to say on behalf of Sakib is that I don't think he's a sir yet. So you don't have to serve him.
Yeah,
but if you want, you can serve me.
Sirs, yeah.
You can serve me though.
Call Sakib and Raj.
Yeah.
In Canada, it sounds very odd.
Yeah. No, that's good to know, Sakib, that some of your videos are being put to good use.
Yeah, no, I'm very happy about that. Are those the seismic ones you're talking about?
Yeah, yes, sir. Yeah. Sorry, I'm sorry.
Yeah, no, that's okay. That's okay. I don't mind either way. So what I think now with the fatigue one too, we will be putting those out, and those will be very similar. And but I think this is going to be even more practical on the fatigue side because we are collaborating with a different software company, Sophistic, and I'm going to be doing some numbers. I'm going to be actually solving a couple of examples. So the first webinar is giving you the background on fatigue, more on the structural steel side, because on the concrete side, really you're just checking it for the rebar, which is rather simple. It's a lot more involved a check for steel, and it's very important because you can bring about failure in your structure due to fatigue, even without overloading your structure. It's a very important thing, and we've had lots of failures, and we've also had lots of cracking in a lot of members in many bridges around the world that are made of structural steel. So basically you're looking at your load-induced fatigue and then also distortion-induced fatigue, which is a whole other kettle of fish, which I'm going to be talking about a little bit. And that fatigue category, the distortion fatigue, is more strain and displacement based. But really right now what we do in the codes is we detail for that. So it's quite important that we understand the fatigue side of things, because you are quite likely to have a lot of damage. And I'm not sure, I know there are lots of steel structures here in Canada, very few in Pakistan that I know of, and I don't know what it's like in India. It's probably still more pre-stressed concrete driven market, like as compared to steel, I would assume. But as other parts of the world go more toward, this is something that you have to be very careful about, because it can cause collapse, but it will cause major disruption to your infrastructure by causing a lot of damage. So I'll go through the background, then we'll show you some modeling, and then I'm going to show some actual simple examples of what kind of like the design in the third webinar. So we're doing a 3-webinar series, and then we'll put it on YouTube as well afterwards.
So the thing to keep in mind with steel, guys, is that it's a great material. We all know that it's got great strength, and it's been used all over the place. standalone and in combination with concrete. But with steel, we need to understand that there's two weaknesses, right? One thing is that, as Saki pointed out, it fatigues. So that is a very important consideration. The other one is that it buckles, right? So stability is the other part that you want to be careful of with steel. So it buckles and that it fatigues. And if you can take care of those two, then you can design good structures in steel. Bridges, I'm specifically referring to bridges. Then the third part that you want to be careful about is corrosion protection in steel, right? But that's more of a durability concern. But the first two can really compromise safety, and fatigue can also be quite sudden if it's not taken care of properly, and including buckling. Buckling can happen just like that, right? It doesn't give you a warning. So those are the things that you want to be careful about with steel.
Yeah, and I think, I mean, going to an area like Montreal, for example, in Canada, where we have extreme temperatures, the steel that we use is, you know, we want to make sure that the Sharpie V-notch values are appropriate, and it's, you know, that's another facet that the North American codes address. Perhaps not as important in the warmer climates in the world, but in the colder climates, we've got to make sure that we have fracture, that we have the fracture toughness to account for extreme temperatures when it drops to -40. Steel can, you know, if it doesn't have that toughness, it can fracture. So there's also a little bit of a cold climate consideration, but that's usually accounted for by the type of steel that you would use in, you know, say in Montreal or even in Vancouver. I mean, I think it's mandatory to use that fracture tough steel. So Louis, how has your experience been, just from a Canadian point of view and the eastern side of the country? I'm quite curious to know what your thoughts are. And I think on the seismic side, Montreal after Vancouver is the one area that I know of that takes seismic somewhat seriously. You know, other Alberta or Ontario is probably just waking up to the seismic thing. It's probably not going to be, you know, ever really a big concern. But there are some pockets within Quebec, like, and also vicinity of Ottawa. You know, and Ottawa is kind of a unique setting because on the one side is Ontario, and then you cross the river, and you're in Quebec. So so you'll be seeing a lot more seismic there, and I'm just curious as to what your thoughts are.
Yes, actually, as the last time that I spoke with Raj, I tell him there is like a good tendency, in my point of view, that the people is considered a little bit more the impact of earthquake engineering in bridges. So the clients are a little bit more worried about. And we are getting more projects related. Actually, the owners of the owners of major bridges are interested to know how the bridges are going to perform with actual requirements, because we have major bridges that we built in 30s, 40s, 60s, and that is a reality, I think, in the whole North America, because we have the structures, bridge structures that are old, and now we know a little bit better the seismic performance, how the structure is going to respond, and what we really want to check in those structures. So yes, I am seeing a good tendency in this matter, and for sure around the Montreal area, for sure there is a little bit better than in other sites in Quebec, but yes, I can see a good tendency related. Yes.
And just to kind of, I think, address this thing on the seismic side of things, and Ghassan has also asked this and alluded to it, the next course that I'm going to be focusing on is the seismic design of bridges. Now, what I'm hesitant to do is give you a timeline, because we obviously have to do a little bit of consulting this year, because the last year we were not doing any, and kind of be able to put food on the table for our families and our children. So it's It's something that's on my radar screen right now. That's the next course. I'm not doing a different course. I am going to be focusing on the seismic design of bridges, and I'm going to be doing it so that I am looking at or giving all the information. Like if you think about those 4 webinars that we did, that was just scratching the surface, right? And that was giving the background on the whole thing. This is really going to be a very structured course like this one, not as long. It's probably going to be 8 to 10 hours, and we haven't quite decided if we're going to do one or we're going to split it up into 2. I have to think about that a little bit more, but producing 10 hours of content the way we do it is like a 6-month journey, to be honest with you. Now, I think on the seismic side, and because that course is not going to be, this conceptual course is going to be more application-based, where we'll be showing you the software, we'll be showing you how to set up the load cases and load combinations, and then going and designing things. I think it's not going to be as much of this course has been a lot of effort. It's pretty much taken us the full year to do this the right way. And I want to do the second one the right way. I don't want to just put out something that's, you know, low quality and doesn't give you the value. So rest assured that we are committed to this, and it is going to be coming out in the next, I would say, probably a year's time. Within 1 year or by the end of next year, it should be out, maybe hopefully earlier. I'm trying to see how I can get some help in terms of producing some of the content and you know, put it out there for people that are really interested. I know that there is a lot of interest in that, and Raj and I are committed to putting out the courses on both force-based design and performance-based design. So I'm not sure if we'll do 2, like one on force-based, one on performance-based, or one, and most likely it'll be 2 separate courses so that we don't end up again with, you know, 20 hours or 30 hours of content. People are just, then people become a little bit hesitant because it seems like a lot of work. So hopefully we'll just chop it up into 2, and people can take the first one first, the force-based, which is more simple, then go to the performance-based. And I'll be talking about pushovers and response spectra and soil structure interaction, all of that good stuff that we would do in a design office. So,
and actually, if you allow me, if you can think a little bit about the seismic soil structure interaction, and because I feel there is not a common just to include in the seismic course something related to the geotechnical and the structural, something that to me is pretty much important, like a PY course.
Yep.
Sometimes it is hard just to find someone who understands what is going on with the PY course from a structural and geotechnical side, and it's pretty much important because it seems to me that, okay, you can input in your model one spring, but what does mean that spring? What is going on with this spring? How I be sure that my answer, my response, the numbers that I am getting is the right numbers, because it's a matter of elasticity and stiffness at the same time. So I really, if you can, the next courses I am pretty much interested already. So, and yes, if you can do something about soil structure interaction, it will be amazing.
Oh, and I can guarantee you that I will be showing the PY curves and not just inputting them. I'll be talking about what they mean. I'll be talking about the physical meaning, how to then go back. So the first thing I'll show you is how to use them in a linear fashion for response spectrum analysis, which is a completely different thing than putting in the full nonlinear curve for pushover analysis. And then how do we make sure that, you know, you are inputting the correct stiffness? You do it in an iterative fashion. So I'll be showing all of that, and there is just no way that people won't understand the concept and be able to apply it. So if you're able to apply that sort of thinking, that means you understand it. So I'll also be discussing a couple of APIs, say the API sand model for coming up with the PY curves, the boogie limestone model for the rock, like a typical rock that you can input. So you'll be generating the PY curves yourself, not just taking it from a geotechnical engineer. Now, of course, I'm not going to throw all the PY curve models. I'm just going to show you 2 examples so that you understand the concept, and then show you how to apply them. I'm also going to show you how to come up with springs for spread footings based on the soil properties and what they mean, the 6x1 matrix, and what it is that means. And then how can you make sure that you're going in with a certain stiffness, but the answer might be off the chart, off the graph. How do you bring it back and capture that soil structure interaction appropriately? So I'll be talking about all of those things. I'm not just going to say, oh, here it is, and this is how you input it, and you run the analysis, and that's no. I'm actually doing some research work with a student right now, and with one person I was doing it, and this is the second person that I'm training right now. And I had to show them all of this stuff. And that's where I feel a bit more confident, because it's our own research, and I will be bringing in some of those steps into this course, because that material is we're coming up with that material right now.
And the other thing that I really want to tell you is about, in one of your lectures, you just put a phrase like about the pier walls. The pier walls, because they are heavy, the mass, the high content frequency of this earthquake. So it piques my curiosity. I went to the code, and I found in the commentary that in the Canadian code that say, okay, there are not that much experimental data about so the behavior and also about that. So I think that is an interesting matter to understand a little bit more. And when I saw this note, I just pick a picture and send you to my advisor of the research, and then told him, okay, here there is you need a student to work in that one. So
yeah, so I think some of it comes from my personal experience. So what I've seen is that if you have massive pier walls, and especially in a place like Montreal, for example, where a lot of the times you guys are in rock site conditions, where you will have high frequency content coming through quite a bit. These massive walls can start to vibrate, and their mass can be excited. It's all it is really the frequency content in the earthquake and the natural frequency of your structure. So if you think about a regular bridge with 2 columns, most of your mass is in the deck. Most of your mass is not in the pier. But when you're looking at these massive wall piers, now you may have a ratio of 1:1. So if you're sitting in Mexico City, where there is, amplification due to site soil amplification, and whatever is coming through is going to get amplified to 2 seconds, well, your massive pier wall may not amplify anything. It won't feel anything, right? But if you're sitting in an area where you have a lot of energy in the short period range of the response spectrum, then there is a likelihood that you site. And we've seen that in one of the projects. When we went to analyze some of these, one of the bridges, one of the abutments was very, very stiff, and our spectrum had a peak. Some of the time histories that we got, their response spectra had a peak at about 0.2 seconds. And that was killing. So this is a slightly different example than a pier wall. But an abutment with like a forest of piles was very, very stiff, okay? And the whole structure over here was fine, but the abutment for one of the time histories was getting hammered, and we were like, what is going on? And it took us a while to realize that if you isolated the thing and you looked at the period of the abutment, it was sitting at about 0.2 seconds. And then when you looked at the response spectrum of the time history, there was a peak which was 5 times higher than the average design spectrum. And so when you ran that time history, all of a sudden your abutment lit up. So that's what I'm saying. Maybe in that sort of little, whatever few sentences that I'm saying is, yeah, there may not be a lot of research done, but going from first principles again, if there is that matching of something stiff with a high mass, and then your earthquake has a high frequency content, with a lot of energy, then you might run into trouble.
But I understand that the way that you find out, it was only with a time history analysis.
Yes, yes. Okay. It's really, you will only find that out unless, because what happens is in a design spectrum, you smooth out those local peaks. Yeah, you're right.
I understand.
Right.
Very interesting discussion, guys. And
just question, Saqib, about the course again. Are you going to show like some example for the time history analysis?
Yeah, so what I am planning to do is at some point, to be honest with you, I think I want to do a separate time history analysis course. In this one, what I want to do is restrict myself to response spectrum and pushover, and also the uniform load method. I might touch a little bit on the theory behind the time history, and I might give you some like a case study, but not go through an actual sort of example. It's still up in the air in my head, like, because again, if time history on its own can be easily a 10-hour course to give you some good value, right? And if I try to bring too much into this one course again, then I think I might overload. So my idea would be to maybe touch on it, but then at some point in the future, I might do a course on time history if there is an interest. Because we are doing lots of time history analysis right now. So to bring that in would be some effort, but it wouldn't be out of the world effort.
Okay.
So one of the things we were planning on doing is just try to get some feedback from our community on, what they would prefer in terms of topics for the next few courses, right? And I do see already that there is a high demand for Seismic, unless I hear otherwise, but just from this discussion seems like people seem to be pretty interested in it. But we would do a poll, Saqib, still in our community, and just ask everybody for feedback on, there's several topics that we can cover, and we'll put them out in front of you. And then getting that feedback would be useful because we know which topics have more demand than others, right? So that's going to determine the next course of action. Saqib already pointed out that there's a limitation, on time, as how much content we can put out, just the two of us, because we are engaged in consulting, right? So,
and to be honest with you, this is not making us rich, by any stretch of imagination.
Well, and that is why producing something that there is a bit of a demand for just helps us out a little bit more than something that doesn't have so much demand. So your honest feedback would be valuable. But coming back to this particular course, maybe we could just go around the table and ask everybody that out of all the modules that you've taken so far, and I'm not sure if everybody's taken all the 5 modules, but which one's been your individual favorite? You can also include the examples that you've taken so far. So perhaps you can start with Qasim.
Oh, you mean the best part of this course?
So far for you?
I would say all good, but yeah, the most interesting one again is the fatigue, and the fatigue was good. Yeah.
Okay, good. Arbaz, for you?
I think you're muted. Yeah.
I would say it's module A, sir, because I'm very new to this bridge course, so I would say module A.
Okay. Yeah.
That's good to know, because we know that the very fresh engineer would derive a lot of value out of A, whereas people like, Luis, or people that have been introduced to the structural systems may just be like, okay, yeah, it's a refresher. But that's why we put it in, because we wanted to cover this for, the absolute beginner too. Otherwise, if you start from module C and you start talking about girders and stuff, and you'd be like, okay, I don't know what the hell he's talking about. What is this wall that is uncoupled from the abutment? What is an abutment, So, no,
Sridhar, for you?
I think apart from the importance given to seismic, I distinctly remember those 2 lectures where you, Mr. Raj sir, where you talked about those advanced bridges.
Okay. So that would again be module A.
Yeah.
Okay. Now, there is a few other folks within your company that are taking this course, right, Richard?
Yeah.
Are they all progressing at the same pace, or do you know where they're at?
I think they are at like 20%, I guess. I am in touch with one other colleague.
Mm-hmm.
So I constantly talk to him. So I just generally ask where is your progress. So he told me he is not getting much of time. So
Okay.
he's at 20% as of now, I guess.
Okay. All right, good. What about you, Harry?
Module C and the project one, where you're beginning to put everything together and some of the rule of thumbs. I think for me personally, the rule of thumbs have been really powerful, pieces of information for me, because now in my first year, I always wonder, I was given a bridge, 3 multi-span continuous concrete, and the layout was already done. Everything was already laid out for me. So I just took it, ran it in Conspan, designed it in 3 hours or so, and took it just to final design. But then during my review, then they asked me, so, what was your experience on that? And I'm like, well, it seems like you guys already did all the thinking for me. Yeah. So like, I have no idea like what went, behind the scenes, why the piers were, or why the span, was this length, the middle span, was that length. And so I always for me, that's when I kind of realized that the real engineering took place in the preliminary design.
And that's a very good observation. And that's really what we're trying to disseminate through this course, that real engineering that you point to, like where all the decision making is done. And hopefully these 2 projects is where we try to bring that thinking together with, so many constraints that we impose on the site, and how you come up with different options, right? How you make those decisions. So I'm glad that you picked up on that.
Yeah, it's very few engineers sort of at the beginning of their careers, the first 5 to 7 to even 10 years, that even become tuned into this sort of thinking. And that's been our sort of like the point that we're trying to get across to younger engineers. So I'm really happy, Ari, that you've already picked up on that, because most people will go for a long time and not think about these things, right? They're always given that starting point, and that's where they pick it up. But then if you want to progress, you really have to do the thinking to get you to that point.
Yeah. So from that perspective, that's made it really worth it for me, because now like I can even go back and for a steel structure. I have not done a steel design yet. I finally started doing some steel design this year or the last couple months.
Right.
But even with the rule of thumbs that you guys already provided, I can now, like, even if they give me a final layout, like I can kind of go back, do these preliminary sizes make sense?
Yeah.
So now I can at least, maybe guess, what went behind the scenes, and or even if I'm checking something, I can pretty quickly, oh yeah, these steps make sense, or no, it's undersized within maybe the first 20 minutes or something.
Yeah.
So
that's very good.
Very good.
Pretty useful.
That's really good feedback. Let's catch the same feedback from Luis. Which has been your favorite module so far?
Actually, to me, it's hard to say, because actually I am kind of passionate about bridges. So you bring this new word to me with the whole course.
Okay.
So no, I think there is a huge quality in the course, and that is an amazing thing that you did. And I think it is a pretty much complete course. And someone told to me that it takes at least 5 years that you can call yourself working in bridges, that you can yourself call you as a bridge engineer. So it's like you're taking a shortcut with the course.
Yeah. That's really encouraging. Thank you very much, Luis.
That's encouraging.
Yeah. I guess one thing I had to ask everybody was that we did throw in, those lessons on constructability with girder bridges. I touched upon access and erection of concrete and steel girders. And again, more from a designer's perspective, the idea is not to turn everybody into a construction engineer, but just again, rule of thumb ways where you can determine, which would be a feasible way of building a structure while you go about designing it. Did people find that useful? Because I think that sort of thinking should be encouraged for especially designers, that they've got to think about constructability while they're configuring that bridge. And Khazan, I'm curious to hear your thoughts on that, because you've been designing bridges for a long time, right? You thought that information was relevant? I don't know if you're still on the line.
I didn't hear everything, Raj. Can you repeat the question?
Yeah, my question was related to the constructability lessons in the course, and your thoughts on how valuable that was to be included as a part of this course.
Oh yeah, for sure, it was very useful. Like constructability, it's a big part of the design process. Yeah, you want to make sure when you design something, it's constructible, and that in my experience, like sometimes we run into problem like while execution during the construction, and
yeah,
it would be good if you think about it beforehand, like before like during the design. That will be really good, like in terms of like for the construction and the schedule and for the client satisfaction. Yeah.
So Harry, you talked about the steel bridge that you're working on right now. So one of the things that you're doing is just going back and checking with the rules of thumbs that we've given you, rules of thumb, if the proportioning is correct. Perhaps the other thing that you could do is, again, just sit down with the simple rules that we've given you for constructability of those steel girders, and just figure out a very simple and a feasible plan given the site, that okay, how would this steel be actually put up by the contractor? At least come up with one feasible method of doing that. I think that's really going to open up quite a few light bulbs when you start thinking about the site, where material can be brought in from, where they can position cranes, where they can lift from, and then it's going to start going into, well, do they need one crane or two crane or a tandem lift and those kind of things. But it's just good to go through that mental exercise, because it's going to make you learn a lot more about your structure. And how these Lego bits actually go together on site, right? And then you might start making some other decisions than what you're making. So one example would be that if you find that, perhaps doing conventional erection requires just these ginormous cranes, you might have to think of another method that perhaps could be overhead, such as launching, and it might then influence how you design your bridge. It might require that you detail it in a way that you split your bottom splice plate so your a roller can pass through. You keep the soffit of your bottom flange flush, and wherever this thickness changes, you actually take care of that in the web, and things like that would change based on which would be the most feasible method of actually erecting your girders. So it is important that you also apply some of those principles as you work on future bridges. You not just look at the proportioning rules, but also apply the constructability knowledge that we've given you. And I think it is going to be quite beneficial once you start applying that.
Okay.
Yeah. Okay, guys, so I think we've gone actually past an hour, and thank you very much for everybody's time. But if there's any questions as they arise, feel free to ask them through the discussion boards on your lessons. You can also ask questions through the course community or directly just email us, right? And
I know that there are a couple that are awaiting a response or two from me, so I'll be responding shortly to some of them that are out there.
Yeah, and soon we should complete the course. We should upload everything by the end of the month, hopefully, and then we're looking forward to seeing who can complete it before anybody else. I think right now,
if it gets resolved tomorrow, believe me, I'm making the video straight away. It's just a matter of how quickly this comes in. So we're putting all the pressure we can, and we'll get
I think right now there's maybe 3 or 4 people, including Hassan, who are just waiting for us. They've completed.
I'd rather not hold anyone up, right? I want everybody to deliver on our promise, and they finish in a timely manner. So.
Okay, and one other thing, I think we've got the spreadsheet where we've done the design for the Shanders, and I also have a spreadsheet for the piece. I believe everybody would be interested in getting that spreadsheet, correct? Or would you guys want to make up your own? Because I do give a lot of like details and before going on to the spreadsheet, so you can make up your own. But if people want that spreadsheet, we have no issues. But you know, we could share it with everybody. So
Yeah,
just
I
let
would
me know
like
now.
to.
You would like to get those?
Yeah, no, I think we should upload that, and people can then choose to do their own and then compare to ours, or they can go to ours. And but you know,
I'm just concerned they'll find a lot of errors in that.
well, then they can help us correct the errors, right? It's a team effort, isn't
Yes.
it? Like it's
Yeah.
I think of
Absolutely.
this as knowledge sharing, not just us talking to you, but also learning from you guys, because everybody brings in, you know, certain experience and diversity. So I think of it as, and I think Raj is the same way. We think of it as a two-way street. So if there is a mistake, let us know, and we'll be happy to correct it. I mean, we're not angels, right? Like any instructor can make mistakes. So please feel free to correct us when you think that there is something wrong in the content or approach, or something we're saying doesn't make sense. Point it out to us, please.
Example 2 would be interesting because I've learned a lot from Saqib on that. I executed that example, especially with the seismic. I had to seek a lot of guidance from Saqib. That's not really my forte, but I did it just because I also wanted to learn. But hopefully it makes sense. And
no, it does. I've listened to things, so.
Okay. So Saqib is
you
actually.
can see we're also actively learning as we go, right? So.
Out of curiosity, how many spans is this? Is the example?
Yeah. So the piece one. Okay. So the piece is. So there's a few different configurations that we look at over there, right? There is a 3-span configuration. You know, the piece example, we fashioned that on a design build environment. So that's different from the Shanders. Shanders is a design build where you're working directly for the owner, right? So you'll also notice in the way we approach the second example is different because we're working directly with the contractor. So what happens in a design build project is that you get a baseline design that comes as a part of the bid documents, right? So there is a baseline design that the owner's engineer has created for you, and that's a 3-span structure. So, you know, we brainstorm at our end and we come up with a few different configurations, and there is the 3-span, but we also come up with a 2-span configuration, and then we evaluate them just the way we did that on the Shanders, except we don't do a multi-account evaluation. It's mostly based on price. As long as these alternatives meet the project criteria, there is a couple of ATCs, we call them variations in Canada, or in your part of the world, Harry, they're called alternative technical concepts. Just mechanisms to maybe challenge the project criteria. But overall, you know, there's 2 or 3 different configurations that we develop and we price out, and then we pick a preferred one. And that's the one that's, you know, quantified and then priced out by a contractor to bid. So to answer your question, I don't want to maybe leak out the suspense before you actually get it, right? So I don't want to tell you which one actually wins, but you know, we are looking at a 3-span and a 2-span situation over there.
Okay.
Right. So we wanted to keep it different from Shanders. Shanders is mostly a 1-span situation, whereas
this is a multi-span.
It goes into a multi-span. Right. Okay.
All right, guys. Thank you very much for your time, and it's very nice to see all of you in person. Well, not really in person, but virtually. Put some faces to the names, and wish you all the best. And we'll be in touch. I mean, we plan on doing more of this one-on-one interaction. So please join us whenever the opportunity arises and you have time.
Thank you very much, guys.
Thank you.
Nice meeting everybody.
Thank you.
Bye.
Thank you.
Thank you so much.
Bye.